Hello everyone, and welcome to the Making Your Organization Scalable with Multi-Resolution Mapping webinar, the second webinar in the Transformation to Automation webinar series. My name is Richie Barra. I'm a marketing specialist here at Esri, and I'll be your moderator today. This webinar is being recorded. We will send you out an email afterwards to point you towards the recording if you'd like to view it again or share it with your colleagues. There will be a Q&A section at the end of the webinar. You can type your questions into the questions window, and we will address them at the appropriate time. There will also be poll questions that give you the opportunity to interactively respond to questions and see the collective results. Note, individual results will not be published, just a percent response to each poll. I'll now turn it over to Mark to introduce our presenters. Mark?
Thanks, Richard. This is Mark Seigan. I'm the industry manager for mapping and statistics industry here at Esri. I've been working for 34 years in GIS and mapping, including management positions at Esri, NavTech, which is now here, and Rand McNally. I'm participating in the United Nations Committee of Experts on Global Geospatial Information Management, also known as the UN GGIM, and I'm on the board of directors of the International Map Industry Association. And I have with me my colleague, Amber Bethel. Amber?
Hi, I'm Amber Bethel. I'm a product engineer for the topographic mapping team at Esri, and I've been doing that for about 15 years now. In my role as a product engineer, I get to help drive some of our software products, in particular the production mapping and defense mapping solution products. And because we are part of professional services, I also have an opportunity of working with a number of mapping agencies to help them implement multi-scale mapping. Back to you, Mark.
Thanks, Amber. Today we're going to look at automation to transformation. Then we're going to look at multi-scale mapping using that automation. And we'll show you a case study of one of our customers and how they've done multi-scale mapping using automation. Many organizations are challenged with providing their authoritative information most effectively. This includes how to best deliver the authoritative information their customers need at an affordable cost. How to produce many different information products, including multiple scales of maps cost effectively and from a single authoritative point of truth database. And having to maintain multiple databases for each production line producing different scale products. Today we're going to show you how you can automate your production processes to reduce your costs and the delivery time to your customers. Then we'll look at multi-scale mapping from your single point of truth authoritative data, enabling you to deliver your information products quickly and efficiently to your customers. And finally, realizing significant savings of your resources by collecting data once and reusing that information to update your multi-scale information products. First, automation is referenced throughout this webinar, so I want to provide a quick overview of what we mean by automation. ArcGIS provides the ability to automate your organization's production by applying your mapping rules to your current authoritative data and running geoprocessing tools through Python scripts in order to generate the maps, geospatial data, and other information products that you have. That automation is used heavily in the multi-scale mapping. ArcGIS enables you to manage the high volume collections of data, then produce your geospatial data and information products, and quickly share those products. ArcGIS also manages your data, your specifications, including your mapping rules and your production operations as you collect, manage, produce, and share your information products. And when I say information products, I'm talking about the geospatial data, maps, web maps, and apps. The goal of multi-scale mapping is to automatically produce any desired output scale data or cartographic information product from a single authoritative best scale database, which you maintain within your organization. So now let's look at the high-level processes that can be used within the ArcGIS platform to automate your multi-scale mapping efforts. The process starts with data automation, as I mentioned earlier, to create data that is appropriate for the output scale. First, the quality of the best scale data should be assessed to determine if it's ready for automated generalization and mapping. Automated generalization is the process of modifying the data to be represented at multiple resolutions or scales. Generalization has a tendency to magnify any existing errors in our source data. So tools and techniques to clean and prepare the data for automation may be needed to achieve a better output result. This includes running automated checks on the data. Once our data is prepared, automated generalization processes are run to transform the data. This is done using two key techniques. The first is feature generalization, when features are assessed individually. In this case, the best scale data contains very detailed building footprints. For the output result, each building is individually assessed based on its size. Very small buildings are removed, medium-sized buildings are converted to points, and large-scale buildings remain as polygons but have some of the details simplified. The second technique is contextual generalization, where context of multiple features or types of features are considered when operating on the data. For example, the density of building features can be assessed to determine where built-up areas should be created. Contextual generalization can also consider the topologic relationships, such as the connectivity of road networks or adjacent area features. In this example, there's no gaps or overlaps between the river and the vegetation area features in the best scale. When the detail of the river is simplified, however, for the output, the generalization processes maintain their coincidence with the surrounding vegetation features. At this point in the workflow, data has been created that is appropriate for the output scale and is ready to be used to generate the multi-scale data products. Using automated workflows like we saw earlier, generalized data is used to automatically generate multi-scale data products. Some organizations stop the multi-scale mapping workflow at this point. These are organizations where the end goal is only to produce the generalized data products to generate multiple scale data products. For those organizations that are also creating cartographic products, we'll pick up that workflow in the map automation phase in a few minutes. Now my colleague Amber Bethel will demonstrate more on the data generalization used to create the multi-scale data products. Amber?
Thanks, Mark. All right. At this point, you should be seeing some data that we have over Frankfurt, Germany. This is our best scale data, and as you can see, it's actually pretty detailed. You can see we have pretty much every stoplight, every crosswalk, even every tree that's in this urban area of Frankfurt, Germany. Now, today I've been tasked to take this best scale data that we have and create a map at a scale of 1 to 50,000. So if we zoom out to about a scale of 1 to 50,000 and take a look at this data, you can see that there's really just way too much information here for us to cleanly depict it at that scale. And it's just too cluttered, right? And so we're going to leverage generalization tools and techniques like the ones that Mark described to automatically create data that's more appropriate for that scale. So if I drag this other window to the side here, you can now see data side by side. Let's zoom back into the urban area. And you can begin to see how some of our data has transformed. Now on the right, this is the result after we've run automated generalization techniques, but before we've done anything to make the data look pretty, right? The data's been symbolized, but you can see that there's still some features drawing on top of each other. That's expected. We'll talk about how to clean that up later. All right, so let's explore some of the ways that the data has changed. If I zoom in just a little bit more and start scrolling around a little bit, maybe pan to the side here, let's look at the roads, right? So you can see that there's a lot of roads in this particular area in the base data, and you can see that there's fewer roads in the generalization results. Now, part of that is using thinning techniques to remove the lesser important roads. So here you can see some orange roads. Those are a lower classification than the red roads. So you can see that those disappeared instead of the red roads in this area. But at the same time, we're maintaining the overall pattern of our road network as we do our generalization. So some of these key features in the road pattern remain. And so it's a combination of looking at the classification of the roads, the density and pattern of the roads that we use as we go through and thin them. Now, we haven't just worked on the roads in this area, we've also done some generalization of our buildings. So you can see every single black building footprint, pretty much every building in downtown Frankfurt has been collected in our base scale data. But again, that's too much information to depict at 1 to 50,000. So we made the decision for our purposes that we wanted to create a built up area and only keep key buildings that are within that built up area. So you can see a light gray polygon showing up in the background on this on the generalization result, and that's the built up area that we created. Within that built up area, you can still see some buildings, some of the key buildings, like in this case, the main train station in Frankfurt. Let's see what this building is. The embassy, some churches, some hospitals. So all of those important landmark or key features are kept, but we've created this built up area as well. Now, in addition to building and roads, we can also work with our more natural features. So if I jump over to an area outside of the downtown urban area, you can see that outside of Frankfurt, there are some agricultural areas. All of these yellow features are agricultural polygons, and all of the green are types of vegetation. Now, one of the things that we want to make sure of in our data set is that there are no overlaps or gaps between any of these types of features. When we zoom out again to something, this isn't even 1 to 50,000, but you can start to see that these symbols become sort of blurry and cluttered. So we want to get rid of all of the smaller features, but at the same time, we don't want to introduce any gaps. So some of the techniques that we use is if we were to get rid of this small vegetation, rather than just deleting it, we would convert it and add its geometry to some of the surrounding agriculture. You can see a similar sort of thing happening with our hydro and vegetation over here, right? In this case, in the base data, our river is wide enough that we want to depict it as a polygon, but it's too narrow to depict as a polygon in our output scale. So in our output, we've just depicted the center line. And if we turn off the hydro surface here, you could see that there would have been a gap in the vegetation. But again, rather than just deleting or hiding that hydro surface polygon, we've decided to use techniques to merge and fill in those areas of agriculture and vegetation rather than leaving those gaps. So all of those are different tools and techniques that we use to generalize our data. Now, how do we put that together into something that we actually leverage? As Mark described early on, we use a lot of geoprocessing in Python. And with geoprocessing, we have individual tools that perform different operations, like this one, delineate built-up areas. That's the tool that we use to create those gray built-up area polygons. We've got other ones to simplify and smooth, and really dozens, if not hundreds, of geoprocessing tools that we can then combine together into a series of models. And those models control and have the orchestration information about how we manipulate our features as we go through the different scales. So you can see that we pull in different features and we perform different operations, and this model then tells us how to process our features. Now, once we've captured all of this information in a model, we can reuse it over and over again on different data sets that have the same schema. So if I jump over to a different pro map, you can see that we're looking at a different geographic area. In this case, it's Mount Desert Island, which is in Maine. The majority of the island is made up of Acadia National Park with a few small towns and campgrounds and those sorts of things. So it's a very different geographic type of area than Frankfurt that we were looking at before. If we zoom in a little bit, though, we can see that we've performed all of the same generalization techniques because we've run the same models. So in this area, which is a town called Bar Harbor, you can see that, again, when we take those buildings, we create the built-up areas. We keep only those important buildings, like a fire station. You can see that we thin out the road network, again, keeping the main patterns of the roads. But here you can also see some other things that we've done to our data. If you look at the coastline here and the ocean, because this is a coastal one area, you can see that as I simplify one of these features, the coastline or the ocean, I can maintain coincidence between the two. So all of these, again, are various generalization tools and techniques that we leverage to take our best scale data and produce something that's appropriate for scale. In this case, we've built our models to produce an output product of 1 to 50,000, but you can use these same tools and techniques to produce data at any scale. And at this point, I'm going to hand it back to Mark, and he's going to tell us some of the ways that we can use this generalized data to produce stylized.
So sorry about that. Just want to remind folks to, if you have any questions, please put them into the question window, and we'll answer those at the end of the webinar. So we've looked at how data is generated for multi-scale mapping from a best source of data. However, many organizations still need to also create a cartographic or stylized product, which requires the workflow to continue into the map automation phase. Cartographic products often include data that is not needed as part of the best scale data. For example, when working in ArcGIS Pro, you not need features that describe the map coordinates because the information is displayed dynamically. However, the coordinate information may be required for a printed cartographic product. Map automation begins to ensure that all of the necessary cartographic data and attributes exist on the data. This can include symbolizing the data the way it will be depicted in the end product, and defining textual information like labels or annotation, or creating grids to depict cartographic information. The final step in the process is cartographic finishing. This is the process where the final product is refined or created. Cartographic finishing can include hiding, masking, or moving the position of symbols or annotation to improve the legibility of the data. In this case, two buildings that are close to each other are automatically shifted apart, so each of them can be identified individually. Annotation is moved because it's conflicted with a grid line, making it difficult to read. And symbols may also be rotated or otherwise adjusted to improve the appearance of the data. Cartographic finishing can also include creating or updating surround information in the product layout and preparing the product for printing or exporting. At this point, you've finished creating a product for a single scale, and the process can be repeated for any number of additional scale products. All or part of this generalization workflow can be used across the Esri ArcGIS platform to transform your best scale data into data that is appropriate for any output scale products, including data and cartographic information products. Now, Amber will demonstrate the cartographic finishing as the final step in a multi-scale mapping process. Amber?
Thanks, Mark. So we want to now take that data that we've generalized over Frankfurt and produce something that looks like a printed cartographic product, right? So how did we produce this PDF? If I jump back over into ArcGIS Pro, what we're now looking at on the left is the data after it's been generalized, and on the right is the exact same data after we've performed our automatic cartographic finishing techniques. So if we take a look at some of the differences between these two, the first thing that you might notice is that some of the symbology has changed just a little bit. It takes a little longer to draw, but you can see now that as we have each road junction, that the symbols look connected. And that's just a symbol draw option and technique that you can turn on and off for your layers. But it gives a better cartographic appearance and allows you to show features that are over and under others. Additionally, you may see some other things showing up here that aren't in the generalized data. So you can see all of the different grid lines that are showing up. Again, this is cartographic data that we produced that we didn't need in our GIS database. You can see that there's some text showing up here as well. Again, these are attributes of the data that's already there that we've just decided to label and display as annotation. Additionally, if you look pretty closely here, you might notice that we have contour lines. And again, those didn't exist in our base scale data, but we can depict elevation information as well in our cartographic product using something like contour lines. So we've produced all of this additional information that goes into our cartographic product. And additionally, you can see some of the other ways that we've refined the appearance of the data. So we look in this area, we're outside of a built-up area. And so we've kept a significant number of our buildings outside the built-up area. The density of those buildings is correct for our 1:50 scale database, but once we apply these big black square symbols, you can begin to see that they feel cluttered. Some of the symbols appear to almost draw on top of each other or draw on top of the roads. So we want to perform some cartographic conflict resolution to produce a result that looks cleaner, right? So you can see that as we have this dense cluster of buildings, in the output, there's not quite as many. We've hidden a number of those buildings. We've shifted them a bit away from each other, shifted them away from the roads, and also performed rotation so that the buildings align with the roads. And all of that happens through some automated geoprocessing techniques and tools, just like we did with our data generalization. To point out another area where we've performed some automated symbol adjustments, let's look at our bridges. So by default, our bridges are points, and our point symbols are rotated horizontally, and there's not much spacing between the right and the left side of the bridge. Now, again, using a geoprocessing tool, it can identify the feature that overpasses another. So in this case, the road that overpasses the river, and it can rotate the symbol to that overpassing feature and spread the sides of the bridge so that it's wider than that symbol, the road symbol. So you can see that this bridge is spread further than this one. You can see the rotation angle applied to some of these bridges. And again, these are just various techniques that can be automatically applied to your data. Once you've performed all of the techniques and run all the tools that you want to refine the appearance of the data in the main map, that's where you begin to construct your layout or apply your data to a layout and potentially update some of the information that's in it. So in this case, our map has a title, some information about the country. You can see that all of the data, including our grids and our annotation, all of our symbology has been applied. If we zoom in a bit, you can see that there's other information being depicted here. Some of the things that we did automatically is creating this magnetic north arrow. So this north arrow tells us what the magnetic declination is of this sheet if I need to use it for navigation purposes. We can automatically project our map frame as well. So our data started in WGS84 and was projected to the appropriate UTM zone. Again, all automatically happening. Some elements may be more static in our map, so our scale bars and our legends may not change from sheet to sheet. But then there's other information like what are the map sheets that are around my current extent? Or what are some of the key features that are around my current extent? And all of these, again, can get added to a layout and automatically updated using either geoprocessing or Python tools and techniques. So, in this demonstration, I showed you how you can take that best scale data. So if we flip back over here, we've gone from something that looks like this to something that looks like that and put it into a map, right? And again, all of the ways that we did this were automated using geoprocessing and Python. And with that, I'm going to hand it back to Mark.
Thanks, Amber. So national mapping organizations have a typical workflow for generating their information products, which includes data production, processing, cartographic production. These same workflow processes can be repeated across all of your various scale products and production lines using the automation that Amber was just talking about. So if you can integrate those multiple production processes, you can reduce the resources you need to produce different scale products and different production lines. The principle of collect or manage once and reuse many times is known to provide significant cost, labor, and time savings. So if you use the 1 to 25,000 scale data to also generate the 1 to 50,000 scale data, and go on to produce the 1 to 25K and the 1 to 50,000 scale data and the derivative information products from that same currently maintained data, you gain significant cost savings. You can minimize redundancy in multiple production lines and leverage your data to produce more products with fewer resources. You can also automate your cartographic processes, as we saw in Amber's demo, to further reduce the time and resources needed and improve the currency and the quality of your information products. So now considering multiplying that efficiency across all of your varied scale products and the production lines you have, and it results in significant time and cost savings. Let me give you an example of this with one of our customers. The Dutch cadastre is the Netherlands cadastre, land registry, and mapping agency. It maintains the official registries for the cadastre and the topographic data for the country. This includes being responsible for updating the nationwide topographic data and maps at scales of 1 to 10,000 scale, 1 to 25,000, 1 to 50,000, all the way up to 1 to 500,000 scale data. They've had the primary goal of modernizing their topographic map production. They were faced with significant challenges that all came up at the same time when they got started. At first, the currency of their data was updated every 5 years, but their legislature of their country mandated that it be updated every 3 years. At the same time, they experienced significant budget cuts, as well as staff cuts. And their management stipulated that no customization would be used in the new production system. Dutch cadastre were able to accomplish this, reducing the time it took to update their data and maps from 5 years to less than 2 years. They did this by updating their topographic 1 to 10,000 scale data of the Netherlands, which is their single authoritative source of their topographic mapping. Then they used their data and automated workflows to generate the 1 to 10,000 scale, the 1 to 25,000, the 1 to 50,000, and 1 to 100,000 scale digital maps, web services, print maps, maps for apps, all of the products that they create. In the words of Ben Bruins at Dutch Cadastre, he's the product manager for topographic mapping at Dutch Cadastre. He said the national mapping organizations worldwide share the same objectives: to make better maps, cut costs, and improve customer satisfaction. The Dutch cadastre succeeded in this by transforming the production of geoinformation with the development of automated generalization. Today, we produce maps 5,000 times faster at 25% of the production costs, and our customers are very satisfied. So on the left is the original 1 to 50,000 scale topographic map for the Netherlands. It used to take 28 cartographers 5 years to update. On the right is the new 1 to 50,000 scale topographic map, and that took 1 cartographer 3 weeks of processing after the data was updated. This was 100% automated. This is how they calculated the 5,000% time reduction. ArcGIS is what enables you to do everything that you've seen today, all of the automation, the multi-scale mapping. It enables you to collect, produce, manage, and share all of your multi-scale mapping information products. So how do you get started with multi-scale mapping? First, you should start with your Esri distributor or Esri account manager. Many of our customers have worked with their Esri distributor and Esri to do a proof of concept and done training coupled with technical support. Others have employed jump starts and workshops to create a roadmap for your organization. And then they've gone on to implement projects that transform their organization with multi-scale mapping. Before we move to our question and answer time, I'd like to remind you about the other webinars in our Transformation Through Automation web series. You can view the previous webinars that we've done on automation and register for upcoming webinar on November 14th on Sensing and Imaging the Future. And you can also get videos of this webinar and others. You can find them at the link below. So we'd like to open up the floor for questions. Just type in any questions that you have into the question window, and we'll get to as many of those as possible. We've got plenty of time here. So one question we've got is, you mentioned Dutch Cadastre doing multi-scale mapping. What other agencies are doing this? Well, there are a number of national mapping agencies that have looked at what the Dutch Cadastre have done using ArcGIS, and they've implemented it in their organizations. The Ordnance Survey of Ireland has used their 1 to 1,000 scale single source of truth data to generate multiple scale data and information products, similar to what you saw with Dutch Cadastre, although theirs go all the way up to 1 to 1 million scale. The Ordnance Survey of Great Britain have implemented this on a number of their products. And we have a national mapping agency in Asia who've also begun using these techniques. All right, so let's see, just looking to see if we have any questions from the audience here. And so another question we've got is, not every mapping agency does their work in the same way. Is the automation we saw configurable so we can modify it for our own use? Amber, would you like to take this?
Sure. As I kind of described in my demonstration, geoprocessing offers the building blocks, the individual tools that allow us to determine how to process our data. And those tools get put together into a model, and those models are completely configurable to whatever your needs are, right? Yeah, you can adjust them to process the data however is best appropriate for your output goals.
Okay, thanks, Amber. We have another question from Adam. Could I see the URL again on the last slide? And Richard sent that out, but Richard, maybe you could put that into the chat window. I'll also pop up the URL shortener here. It's at the bottom of your lower left of your screen there. And just give you a chance to jot that down. So you can go get again, the recording of this if you want to share this webinar with others, or if you want to register for the next one we have coming up on November 14th. Let's see, we have another question. Are there any pre-made, this is coming from Trevor, are there any pre-made models that could be shared to help me to learn what others are doing, best practices? Amber, you want to talk about those resources?
Sure. For ArcMap, we do have a number of pre-made models that have been already shared out. With production mapping, we have a schema that we call the civilian topographic map model. And with that, we have some sample data and some sample generalization models, and all of those are available up on GitHub, and potentially I can share the link with you in the chat window in a minute. So all of those models, they're a bit old at this point, but they're a good starting point to see generalization in progress, because you have the sample data there and you can see how we built those models. Additionally, if you are a defense customer, the defense mapping product has some generalization models to show how to take your data from 1 to 50K to 1 to 250K. And those are available as part of the defense mapping solution. They're built on the TDS models. So those are what Esri provides for free as samples. We are working on some samples of generalization models for Pro. We hope to have those available with the next release, but we'll see if that happens or not. So there are a number of pre-made models out there that you can go and grab and try and just to explore. So I will dig up that URL.
Okay, thanks, Amber. So we have another question from Shibani. So how do you handle those data? Should you have a server for your organization? Or is there a specific server to upload those data? So Amber, again, I'll let you take this.
One sec. I need to see that question written out. I'm confused by the question a little. How do you handle data? I'm not quite sure what the question is asking. Generalization and map automation can work with ArcGIS Server. If your data is hosted in an SDE geodatabase, we use that for many of our organizations. We use that as a starting point, and we pull the data out of that SDE and process it to produce our scale-specific data. Additionally, we can leverage ArcGIS Server for that geoprocessing. We have a number of web applications where you can actually pick a map and generalize it and produce the map on the fly. So there are ways that you can leverage Server, but I don't know that I've answered your question.
All right. If not, Shibani can put the question, an addition on that question there. We'll see if we come back to that. So I see, Amber, you've put in the GitHub address, the URL, to locate these models and tools on GitHub in the chat window for everyone. So we have another question from Doug. Have you built any solutions that span both the hydrographic and topographic domains? Amber mentioned, so yes, we have. We've got the production mapping solution, and we have the defense mapping solution. Those are for topographic mapping, but we also have maritime solutions. We have a maritime ArcGIS for maritime charting solution, and we have an ArcGIS for maritime bathymetric solution. We also have aeronautical solutions for charting as well as for airports. Those are separate solutions, but they're all built on top of ArcGIS. They're also built on the same core tools that you saw Amber talking about. And then they have very specific topographic or hydrographic or aeronautical models and tools that are specific to those domains. So they share a common foundation on top of ArcGIS and the mapping and charting solutions, but they also have very specific tools. Amber, I don't know if you want to add anything to that.
No, I think you did a good job.
Okay, all right. And then I guess to your question, Doug, those are separate solutions, but they work together. And we have a number of organizations that do topographic and hydrographic work together. And also have actually created littoral charts, which is a hybrid, of course, between topographic and hydrographic or nautical charts. So another question from Adam is, do you update US political maps, or is there a service that updates the political maps which change frequently? I think, Adam, the answer here is that you could configure all the tools and workflows that Amber talked about for any type of map. We've done it specifically for topographic maps for various scales with different models, both defense models and civilian models. But if you have a specific type of map with map rules you can use these same tools and model them for that. But you would have to do that work to set up your cartographic rules and your data rules. So we have a question from Jose. Are the production mapping solutions available in ArcGIS Pro? And the second part of that is, or are you combining ArcMap and ArcGIS Pro? So Amber, I'll let you answer that.
Yes, the Esri production mapping solution is available in ArcGIS Pro. I believe we've been available since the 2.1 release. Everything that I showed you in our demonstrations were models and tools that were built and run in ArcGIS Pro. And so yes, production mapping is available in Pro. There are still a few gaps. We don't have full functionality of production mapping available in Pro, so there may be parts of your workflow that you're still doing in ArcMap. But overall, most of the tools, especially for the data collection and validation side, have been migrated to Pro.
Okay, thanks, Amber. So Shabani was the question earlier about server, and she's come back and said, for example, in Tanzania, we use OpenStreetMap to upload our data. So I thought if there's a free server for Esri to store the data. So I think maybe that's the, maybe you can clarify that, Amber, for Shabani.
So I don't know that there's a free server for Esri to store the data. I know that we are doing some interesting things with OpenStreetMap. We do have tools to integrate OpenStreetMap data into ArcGIS. You can download data, use all of your edit tools in ArcMap, upload the data. I am not sure. I had heard that we might be hosting some OpenStreetMap data as a vector tile service, but I don't know if that has happened yet. So I'm not sure where we are in that process.
Okay, thanks, Amber. Let me see if I can kind of summarize too. The solutions that you've seen today, the mapping and charting solutions, the production mapping and others, they work on the desktop and the server. They work off of ArcGIS, both desktop and server. We also have our ArcGIS Online, which is our online site, and we've got on there the living atlas of the world. And on there is a lot of content that you can get, including OpenStreetMap is available, so you could pull that data. Amber used that OpenStreetMap data just as a sample data because it was very rich in the area of Frankfurt, and we wanted to use that to demonstrate how you could generalize from a very detailed data set to a simplified data set. So hopefully that clarifies some of that question. So we've probably got time for one more question. I do appreciate everyone putting their questions in here. I think it's made it a very good discussion. Tricia has a question here. Are there any current tutorials on the geoprocessing tools? Amber, you want to take that?
Ooh. I'm trying to think if there are any. It's specifically for generalization. I'm not aware of any like larger tutorials that describe the process of pulling together different geoprocessing tools to produce a generalization model. There should be tutorials and webinars and other like learning center materials on specific tools. Like if you're interested in the generalization tools that are a part of the Cartographic toolbox for generalization. I know that there are some videos and webcasts out there that describe those tools in more detail, but I'm not aware of any specific tutorials on the larger scope of multi-scale mapping or generalization.
Okay, thanks, Amber. So there are, and if you go to the Esri.com site, there you can select. There's training. There's free training online, as well as there is other remote instructor-led training on geoprocessing. If you're interested specifically in how to get started with what we saw today on the multi-scale mapping and the automation with experts like Amber, we have, as I mentioned earlier, working with our distributors or your Esri account manager, we can put together a package that makes sense for what you're doing in your organization, and that could be anything from just supporting you to implementing these, using the models that Amber shared in GitHub, all the way up to coming on site and helping you implement and everything in between. So we'd be happy to talk with you about that. There's a survey at the end of this webinar. Please just indicate if you're interested in that. There's some questions that you can put in there. So with that, I think we've run out of time. Thank you again for everyone for your time, and do look for other webinars in this series. And if you could just take a moment to take the survey that we have, and let's take you a moment, and thank you everyone.